Good afternoon, stats class, and I'm back again with week two Teach It, and we're going to be talking about our T scores. So I'm going to go ahead and get into it. And Dr. Smith, thank you for everything. All right. So first thing, we're going to state what our hypothesis is. So this is going to be H sub O and H sub 1. These are going to be your null and alternative hypothesis. So what we're trying to find is going to be our alternative, or H sub 1, and what we're trying to disprove, or the no change, is going to be our H sub O. So in this example, I'm talking about GPA scores. So these are all GPA scores listed right here on this chart. These are all going to be before and during COVID. So we're going to see which of these scores, if they were improved during COVID, if they were better before COVID, that's what we're going to try and find out. So the first thing we're going to do is we're going to find the mean difference off of this regular 7-step the x value example. So we're going to take all the x's, we're going to line them up. So I have 2.4 over here. That 2.4 student got a 3.0 during COVID. So that's what that 0.6 over here is going to represent. It's the mean difference between each of the x intervals. So we're going to come over here, we're going to add them up. This is going to give us our mean. We calculated both of the means, the same thing like that. We're going to calculate this, we're going to find the mean difference. We're going to add these all up, and that came out to be 3.3 when we added up all the differences between our x values. Once we take those, we're going to be able to plug that back in to the standard error. But first thing we have to do before that is we have to find and do the regular 7-step process. So we're going to take our T-scores, we're going to table them right here, left them right here at the top. I'm not interfering with what we're doing right here down here at the bottom. So we're going to take these scores, we're going to subtract them from the mean, which is 3.008. And then we're going to take that number, we're going to take x minus m, and we're going to square it. So that's why I have all these squared right here. And we have all these values. Once we take these values, we're going to add them up, and that gives us what is going to be helpful for us finding variance. So I'm going to move over here. Once we have this score right here, you can see the arrow. It takes us right back over here. And this is where we're going to be able to find the variance and the standard deviation, which we need in order to find the t-score. So once we take this, we're going to use a degree of freedom, which is n minus 1, rather than using the n score. So that way we know that it's not exactly the same. So D of F is degrees of freedom. We're going to take that, and that gives us 5.570358, and we're going to take the square root of that in order to find the standard deviation. So the standard deviation, once again, is the variance squared, square rooted. So that gives us our final answer right over here. We're going to take that, and we're going to put it right back into this formula, and now we can find the standard error. So we're going to take the standard deviation divided by the square root of n instead of degrees of freedom. So make sure you guys are paying attention to the difference between that and not getting tripped up right there. We're going to take that. We have 7 samples. We're going to take that and divide that. That's going to give us our solution for the standard error. Once we find that, we're going to plug that all back in, and now we're going to find the t. So we have 3.3 divided by our standard error, which is 0.2854465,174, and that gives us 11.560. The other important thing to remember out here is that we also need to check the confidence interval. So the confidence interval is going to be found through the alpha score, which was 0.05, which I had listed right here at the top, which is also really important to know, so that once we do the chart that's also listed right here, we know where our reject points are going to be, and I'll go in a little bit more about that in just a second. Once we have those, we have the 95%. We're going to calculate that. We're going to plug this into our Cohen's d formula, which is going to help us find the effect size. So we're going to take this squared, t squared, which is the score right here, 11.56. Add that by the degrees of freedom, not n, which is 6 instead of 7. I take these. There's the work for that right there. And the answer is 0.957. And with that answer, we're able to know that we need to fail to reject the HO. which will help us when we're down here and will show us the overall answer to what we've been working on today. The effect size is going to be m plus or minus the confidence interval times the standard error. And that's really important to remember. I didn't write that out like that, but I just wanted you guys to know that that is exactly what that is. With these, the effect size, that's important, so it shows the relation of everything to how it relates back to our original hypothesis. With our chart right here, we have 0, we have negative 2.447, and positive 2.447. What is 2.447? That is the t-score that you find at alpha 0.005. So that is what that is. And there's right here, you can see we have 11.56 all the way on the left-hand side, on the right-hand side, way in the positive. And that's why it's going to be that we have to fail to reject.